All right. So I think we are started. I know everybody's like back-to-back sessions. So I'm gonna give them a little time to get in and because I know everybody's excited about this one. Very excited to hear what we have to say. I hope we have good things to say.
I hope so too.
When people talk about varnish, it's never good things, but we'll try our best. Definitely
I'm
try.
hoping we're going to get stumped with some questions here.
I
So,
hope so too.
yeah.
Let's see how it goes because like I know a lot of the people that I see coming in, they are varnish experts.
Oh,
Oh boy.
Amanda, she's going to stump us with some questions, I think.
Yes, for sure. I would love that. Oh my gosh. Because I'm gonna give them a minute again just to get in. Because I know it's a taxi time between sessions. So glad that we don't have to physically jump through these sessions and
Yeah.
y'all can just go from screen to screen.
Yeah.
And that is yes, I know. It's gonna be a good one. So I am gonna start us off a little bit here. So for those of you who don't know, I am Sanya Mathura, and I'm here with the guy with varnish on his shirt, uh, Greg Livingstone. We have such an amazing presentation for you all, covering a lot of different points. Of course, we cover things in the book, and it's a requirement that you have this book with you for the session. So, make sure to get your books out. But I'm gonna jump into the video that we did for you all. Covers everything about different topics in Varnish. And we are just like very excited that we could share this with you today. So I'm gonna pass it over to the video and we will be talking to you soon. Hi, I'm Sanya Mathura, and I'm very excited today because we get to share our book that we wrote together, Preventing Turbomachinery Cholesterol, the Story of Varnish. This is the first time that we're going to be presenting about this book. So, it's very, very, very good to be able to share that with everybody at LRVS APAC today. And it was great being able to write this book with Greg because when I first started in the industry, Varnish was now rearing its head and now coming up as an issue. And the only person that had actual white papers on this was Greg. So I was always going to Greg for advice. So comes full circle and we were able to do this book together. So very excited that we could share this with you all today.
Thank you for that great introduction, Sonia. Hi, everyone. I'm Greg, and what we're going to do today is answer some of the common questions that we often are asked about varnish. So, specifically, well, what is varnish? We'll start there. To flush or not to flush? That is a question. So, we'll talk about that. How do you go about characterizing deposits? Can you actually redissolve varnish back to the oil? How does temperature play into this? How does it impact oil degradation and varnish formation? And finally, how do you go about choosing a varnish mitigation technology? So let's kick things off. Sanya, what is varnish?
What exactly is varnish? Now, I know when we wrote this book, we wanted to make sure that anybody picking up the book could actually start to read and understand varnish and what it means for the industry and all of these other great things. And what we did is that the first chapter in the book, we talked about the basics of varnish. We had to get that done to make sure everybody understood what we were talking about later on. And one of the good things about that chapter is that we give some definitions in the book. And ASTM actually defines varnish as this very thin, hard, lustrous, insoluble deposit. And they say that it consists of a wide range of colors. We know that for sure. And it's resistant to the removal with saturated solvents. Now, that's ASTM's definition. Within the industry, we have so many different definitions because people use varnish and they use sludge interchangeably. And what we do in the book as well is that we define varnish versus sludge. So what we say about varnish is that these are the oil-derived deposits, and they actually adhere to the insides of the equipment, and they cannot be easily removed. Major difference compared to sludge, which we identify as a wipeable deposit. So that's just one of the things to, keep in mind, the differences between varnish and sludge, because they are used interchangeably throughout the industry. Now, the thing about varnish is that you can either have hot varnish or you can have cold varnish. A lot of people are familiar with the cold varnish in that this is when you have the accumulation of the degradation products and they reach a saturation point in the oil, and then they precipitate out of the fluid onto the internals and cause a bunch of different, problems. But this is when you have that drop in temperature. So that is cold varnish. And usually you could detect this with your MBC patch test. With hot varnish, on the other hand, it's when you have, the deposits are actually formed directly at the heat source. So this is when you have like a combination of high speed, high load, and usually get a lot of shear stress in extremely high localized temperatures. So the MBC patch test may not pick up on this one, but a solution to this is actually using like a solubility enhancer. So those are some of the differences between varnish. And we talk about this a lot in our first chapter of the book, where we talk about the basics of varnish, just getting it right. A lot of times in the industry, we get the question of, do I have to flush the equipment or do I not have to flush the equipment? And Greg, we really want to hear your thoughts on that one. Do you need to flush your equipment every single time that you change the oil, or can you get away with it?
Great question, Sanya. Flushing is intrusive, expensive, and carries a lot of risk with it. So why would you want to do it? Well, when your system needs flushing, there's no other substitute. You must flush your system, and there are several reasons that you would look at and consider for flushing. First, if you're commissioning new machines, that's always flushing is always required to remove any of the welding slag and other materials of construction from the loop system before you commission the system. Recommissioning system is another reason that flushing is required. A big reason is if you have a component failure and you actually have chunks of a component somewhere chewed up in your system, that flushing is the best way to get that out. Filter collapse may give you a reason to flush. If you've inadvertently added an incompatible fluid to the system and your whole system now is filled with incompatible fluids, flushing is required. If you're looking at changing to a new type of oil and you don't understand its compatibility, you should probably consider flushing. When you have varnish and oil degradation products in your system in between oil changes, you should flush. And certainly if you have corrosion or paint peeling off, that would be a justification for flushing as well. Now, if you look at this list, you'll notice that actually the vast majority of these reasons because there's been some kind of maintenance issue. So in most cases, after you flush your system out and commission your piece of equipment, you should try to avoid flushing if at all possible, because it's also an indicator that some other maintenance issue has happened. You have sludge and varnish in your system, which can be avoided. You have broken components to your system. So to get to Sanya's question, do you flush in between every single oil change? Well, you don't need to flush if the vast majority of the system is free of deposits and varnish. If you can evacuate all of the old oil or the vast majority of the old oil from the system and the new charge of oils fully compatible, and you're aware that it's fully compatible with the existing in-service oil, then you don't need to flush. Flushing is suggested in between oil changes if there are in fact indications of sludge and varnish, if the current fluid can't be fully evacuated from the system, or if you have compatibility concerns. So I'm not going to get into the wide range of flushing technologies and processes because we don't have time for that right now. We need to get on to the next question. Sanya, how do you go about characterizing varnish and deposits?
Yeah, there are lots of different. So if we were to categorize all the different types of deposits, they would not fit on the slide. So when we talk about the two main categories are organic and non-organic deposits. But you also have water or lubricant derived deposits because there are some deposits that cannot be classified as organic or non-organic. But your organic deposits, those are the ones that are soluble in the lubricant, and it allows them, because they are soluble, they can actually easily transition in and out of solution, but that's based on the oil's temperature. They can be actually formulation derived, thermoplastic, thermal decomposition derived, oxidatively derived, contaminant derived, or even biological, which is very interesting because, it can form any type. Your non-organic deposits, on the other hand, those are like your wear metals and your dirt. And these usually have the classifications, they have some sort of variations of coal or plant life in them for some weird reason, right? And they more than likely they contain some sort of carbon or hydrogen functionality, but they behave more closely to inorganic materials rather than organic materials. So your non-organic deposits, those can be classified, as formulation derived, inorganics, soot, coal, or coke. So those are just some of the differences that you have with your different types of deposits. This is one that we hear a lot. Can varnish actually be redissolved into the oil? Very tricky one there. So I'm going to leave you to answer that.
All right, that's a great question. I first want to start off with a quick definition. Varnish is actually the things that come out of the oil that are plated on the internals of the machine. Varnish is actually not something that's in the oil. In the oil, we have oil degradation products, and then what comes out of the oil we call varnish. So sometimes there's some confusion about that, and that's important in trying to understand this principle. So in order to understand how oil can dissolve oil degradation products in a system, we're going to go way, way back to the 1800s with this dude, Le Chatelier, that developed this in the late 1800s, that really is looking at how systems react that are in equilibrium. And first off, anyone that has such good looking glasses like this clearly is a very smart person. But actually his principle's been widely used both in chemistry and chemical engineering for the last 150 years or so. He's specifically looking at concentration, changes in temperature, and changes in pressure. And in the case of varnish, we're looking at changes in concentration. And specifically, if there's a change in the amount of oil degradation products in the oil sample, in the in-service oil, there's a correlation to the actual amount of deposits that are in the system, the amount of varnish that's forming. And vice versa, if there's a lot of deposits in the system, that will then transfer to the oil until an equilibrium is reached. So if you dump out your varnished old oil that you have varnish all throughout the internals of your system, you put in a brand new charge of oil, what's going to happen? Well, now it's not in equilibrium. So the varnish that's already settled out in the system will actually be dissolved back into the oil. Some of the deposits will, and they'll kind of transition from varnish back to soft contaminants or oil degradation products. If you put brand new oil into a varnish system, is it going to dissolve a lot? Not so much, because actually the solubility of most group 2, group 3 formulations is really, really low. They can't hold a lot of things in solution. So you have a limited capacity for a brand new charge of oil to actually dissolve varnish in the system. But this is why solubility enhancers are so effective. Solubility enhancers will give the oil a huge capacity to hold on to oil degradation products, and therefore you're able to dissolve a lot more of the varnish, taking it out of the system and putting it into an inert, harmless state as oil degradation products in the oil that will stay in solution. So this does explain whether or not varnish can actually be removed from a system through chemistry, and also why solubility enhancers are effective. And if you do add a solubility enhancer to the system, basically what it's doing is it's dissolving one molecular layer at a time until all of the varnish has been dissolved from the components, or at least until an equilibrium is reached. All right, Tanya, question now for you. How is temperature related to oil degradation and varnish formation?
Temperature is a major factor of degradation. Having these varying temperatures can actually increase your varnish deposits. And the thing about varnish deposits is that we know that a lot of times it comes out of the oil when it goes into a cooler area, right? And these are like at your filters, at your servo valves, or the internals of your equipment. But the cooler temperatures are not the only times that they would come out of solution. If the oil is under very high temperature and load, then they could come out of the oil as well, and this could cause localized deposits. In this case, what you would want to have is like an oil cooler, and this could actually help to regulate the temperature of the oil so that the temperature of the oil stays within a more uniform range. Another way you can deal with having the temperature drop is having heat trace lines. So if you have these heat trace lines leading up to the filters, they can also help to prevent electrostatic spark discharge, because these often occur on the last chance filters. And these are the areas in which the oil is a little bit cooler and the valves aren't being used as frequently. So the heat trace lines actually warm up the oil before the filter. And, this could help reduce that occurrence of, ESD, or even, getting varnish depositing on those parts of the filters. Having an improperly sized or malfunctioning heater in the reservoir can actually lead to the oil becoming cooked or thermally degraded. So if you don't have a properly sized heater, then that could throw off your entire system, and you can actually have the oil being degraded at the reservoir in the sump before it even gets to the equipment. So you have to make sure that your heaters are properly sized and that they are not malfunctioning. So that helps in terms of regulating your temperature throughout your system as well. So there are many different methods to prevent deposits, like a lot of them on the market. How can somebody actually choose one that is right for their system?
All right, that's a great common question. So there are several different considerations that you should take when looking at trying to select a varnish mitigation technology. The first one is temperature. Are you trying to treat a system while you're actually online and operating? Or are you trying to treat a system maybe when you're offline and during an outage? So first is temperature. Second is location. Are you offshore having to deal with ATEX, Class 1 Div 2, or some kind of special hazardous conditions? Third is, are you trying to treat varnish proactively or reactively? Hopefully proactively, but we'll talk about that. And then finally, if it is reactive, what actual problems are you trying to solve? So first, let's look at temperature here, and we can look at a range of different technologies. First, starting off with depth immediate filtration. Depth immediate filters actually don't filter varnish out, but they're typically made of cellulose, which is polar, and they're actually attracted they attract other polar constituents like soft contaminants that adsorb onto the media. So they can actually be an effective way at removing varnish. Centrifuges, not used so much, but if you have a lot of water in your system, a lot of free water, that can also pull the degradation products out. Electrostatic oil cleaners, the technology that's been around for many, many years. Thousands of these are installed in plastic injection molding machines. The right application, this is a fantastic technology. Charged agglomeration is kind of the cousin of electrostatic oil cleaners. Instead of charging the particles and then capturing them on a cell or in a collector. You charge the particles half negative, half positive, combine them together in the hopes of them agglomerating so you can actually remove them with normal particulate filters. We have resin filtration, which is essentially using ion exchange media as a selective absorption sites for very specific oil degradation chemistries that are in solution in the oil. And finally, you have solubility enhancers. Solubility enhancers are essentially preventing these oil degradation products that are inert, hanging out happy in the oil. They're preventing them from actually coming out of the oil and actually causing damage. So in the right application, these can be very, very powerful as well. The first consideration being temperature. The first four technologies, depth media filters, centrifuges, electrostatic oil cleaners, and charge agglomeration, only work on suspended contaminants, which are typically when the oil is less than 40 degrees C. And in most operating systems, the oil is above 40 degrees C, typically 50, 65, even higher. So basically all of the degradation products are already in solution, so you need to either look at resin filtration or solubility enhancers. Keep in mind the other technologies work in the right applications. You may be removing inorganic contaminants, you may be filtering the oil when it's cold, so it's not that they don't work, but when you're trying to treat a system online, resin filtration or solubility enhancing is the way to go. And again, it's always preferable to do this proactively, and both of these technologies can in fact be used proactively, basically to prevent you from having any varnish in the future. Unfortunately, most people wait until they have a varnish problem and then react to it, and then they're trying to very quickly put together what type of technology should I install to basically keep my machine up and running. So if you are trying to look at what technology to use based on what problem you're trying to troubleshoot, if you're trying to do this online, again, we have resin-based filtration, we have solubility enhancers, and they both can work in many cases. So if you have high MPC values, if you have valve sticking, heat exchanger fouling, or if you have rapid filter changes, both solubility enhancers and resin-based filtration work really, really well. If you have shear stress deposits, a unique form of high temperature degradation, localized deposits happening in or high bearing temperatures, solubility enhancers are really the only way to go. It's the only technology available to address those. And finally, if you're dealing with other types of fluids, resin-based filtration may not be ideal if you're looking at gearboxes or hydraulic oil deposits, especially ash-containing, ZDDP-containing hydraulic oils. Solubility enhancers are the way to go with that. So hopefully that gives you, in a couple minutes, a quick overview of how you would go about selecting a varnish mitigation technology.
Thank you all so much for joining us and for being part of our first book launch, unofficially, virtual book launch. And let us know if you have any questions.
All right, excellent. Well, I think, Sanya, we have a few questions here.
We
Actually,
do.
some excellent questions. And so let's see, there's a couple that we wanted to kind of answer live here. You want to take the first one with hot varnish and microdieseling?
I know I will start off with that one, Jacob. Thank you so much for asking that. Um, if there's a correlation between hot varnish and microdieseling. So I think when you think about microdieseling, and this is my thoughts, I know you are an expert as well. Microdieseling is where you have entrained air. So if you have entrained air and you're seeing some sort of cavitation or those sort of processes, then you know for sure you're going to have microdieseling. Hot varnish, that would occur in areas that you have like these localized temperatures. So I'm not sure if I can say that there's a direct relation, but I feel like there can be some sort of a spin-off because you need to have that entrained air for microdieseling. I'm putting it back to you, Greg. Anything you want to add to that?
Yeah, I think there are two unrelated degradation mechanisms. So I would say there's probably not a correlation. That being
Mhm.
said, we have seen some situations where microdieseling does occur
Yeah,
in bearings, so in some cases, or maybe a correlation, but in general, we're looking at two different degradation mechanisms. That's a
yeah,
great question.
that is definitely. And I know Breno had a question, and this is very interesting. Is it possible to have unmanned and continued condition monitoring related to varnish? I would love that. Uh, and how can we continuously measure parameters of an oil system to make sure we don't create varnish? So, Greg, you have the first crack at it.
All right. Well, the first thing I just want to clarify is that you can't actually measure varnish in oil because there's no such thing as varnish in oil. Varnish is the stuff that comes out of the oil, and that is something that everyone gets confused with. So yeah, that's the first thing. And so there's no sensor that you can actually put in the oil to actually measure varnish that's settled out in the system. That being said, you can in fact measure oil degradation products online with sensors, and then depending on the formulation, you can then correlate that to varnish potential. So that's something that we have been developing for some time, and so we have several sensors in the field right now that are in fact measuring varnish potential real time right now. So this is something. Varnish potential. I think I said that right. Not varnish.
Potential, yeah.
Yeah, so it is something that, in fact, we can do.
All right. And I know our friend Joaquin is asking about charge agglomeration. Yes, heavily used in Trinidad and Tobago.
I would say charged agglomeration was a technology that was pretty widely used
Yep.
maybe 10, 20
10.
years ago.
Yeah.
Um, in general, you're removing things that are suspended in the oil. So if you come offline and all your degradation products have a chance 3, 4 days to cool down and the oil's nice and cool, then they can actually come out of solution, agglomerate in size. Charged agglomeration works well. But if you're trying to remove oil degradation products in line, charged agglomeration does not really work. So there have been a lot of advancements in technology
Oh, yeah.
since, and so I would suggest resins are probably the more up to date technology if you want to look at
Hmm.
if you want to look at varnish or online varnish mitigation technologies.
Yeah. And I'm just adding to that. Always very important to know exactly what type of varnish or deposits you're dealing with, because that helps you in terms of treating your varnish system. Because you don't want to do a random thing and say, okay, well, this is gonna work for every single thing, but then you have different types of deposits that it would not work on. So always very important. Understand the deposits that you have in your system before you apply a mitigation system. I know Corey has this question about varnish in EHC systems, and can solubility enhancers be used there, or is there more suitable technology? That's a good question, Corey.
Great
It's
question.
a
So one
very
of the
good
challenges
question.
with using solubility, and one of the challenges with putting anything into phosphate ester fluids using the EHC systems is that you impact the fire resistant properties. So you're using phosphate ester fluids because they're self-suppressant. They will self-suppress any kind of fires. And if you add as much as 2% mineral oil or 2% of a solubility enhancer, now you lose the valuable properties of the EAC fluid. So if you're doing this offline, not a problem. Solubility enhancers could potentially be used, but typically we would suggest not putting this into an operating EHC system, so you don't reduce the inherent safety of phosphate ester fluids. Thanks,
Yeah,
Corey. Thanks
that's
for the question. Good to see you.
that was yeah, Corey. Glad you could join us. I know Joaquin has a couple of questions about he's talking about Boost VR in the varnish removal process. Any side effects to using this in the oil or the system components? Uh, do you
So
want to
I'll say
handle
that
that one?
on
Yeah.
a short term, so Boost VR is an older technology that, and when we when we came out with this technology, we said you should use it for a maximum of 6 months. Longer term than that, we don't recommend that. So that's why we've come up with a next generation technology, decon, which can in fact be used long term. Before you add anything to the oil, the obvious thing is you have to make sure there's no adverse impact on additive systems, material construction, or any of the system components. And so we've done some pretty extensive testing to verify that that there's no risk in using that.
All right,
Thank
that's
you.
good. I know Ahmed is also talking about if it depends on the OEMs. Definitely depends on the OEMs. They have different characteristics, different criteria that you need to match, especially for varnish. I'm just gonna try and one more question with your Quinn. Do elements of varnish travel through the system and remain adhered to the walls of the tank? Yes, it's like cholesterol in your blood. It doesn't stay in one place. If it gets loose, it gets loose. My short answer to that. And Ahmed is asking about AI helping to improve varnish. We have the AI panel in a little bit. Think you need to ask that question there, but I certainly hope that we can get it there. I think we've gone through. There were a couple of really good questions that we answered offline that I just want to jump into because I know we're 1 minute over, but have a look at those when you all get some time on the chat. But I don't want to keep you all any longer than I have to because I know you all have another panel coming up very soon. So any other questions that you have for Greg and I, drop us in the chat or connect with us and bother us about it. We are here for today. We are also in the panel a little bit later talking about sustainability. So check us out for that one. And thank you all so much for your time. I
Thank
hope we
you,
answered some of
everyone.
your questions.
All right. Bye for now.
Bye.